Okay, let's look at a couple more examples of solving a 3x3 system. So a system with 3 variables, 3 equations. So the first step I like to do is label these 1, 2, and 3, just so I can keep my work organized. And then I need to decide which variable I want to eliminate. So let's see, the x's, they're all small numbers, none of them are opposites. The y's, I do have opposites right off the bat, so I'll probably go with that. Let's go ahead and eliminate y's. And I'm going to start with equation 1 and 3, because I don't have any modifications to do to these formulas. They're already ready. So I'm just rewriting the equations. And now I can go ahead and add them. When I add them, I get 1x plus 3x is 4x. 1y plus negative 1y is 0. 1z plus 2z is 3z equals 3 plus 5 is 8. I'm going to call this equation A. Okay, now I need to pick 2 different equations. I can't do 1 and 3, so I can do 1 and 2 or 2 and 3. So because equation 3 is negative, I'm going to do 2 and 3. But when I do equation, 2, I can leave it as is. Equation 3, I'm going to multiply that. I want to get this number into a 4, a negative 4, so I'm going to multiply that equation by 4. So equation 2 stays the same. 4x plus 4y plus 4z equals 7. Equation 3, multiply everything by 4. So I have 12x minus 4y plus 8z equals 20. And now add them. So 16x cancel plus 12z equals 27. And this would be what I call equation B. Now, I'm just going to take some time to rewrite A and B. So equation A, equation B. Let's see here. We got 4x plus 3z equals 8. 16x plus 12z equals 27. If I add these right now, will anything eliminate? No. So let's see. Can I make this 4 into the opposite of 16 through multiplication? Sure. I'd have to multiply it by 4 and make it negative in order to make it negative 16. So this becomes negative 16x minus 12z, I'm distributing it to all 3 terms, equals negative 32. Equation B, I'm just going to drop down 16x plus 12z equals 27. Now I can add these. Negative 16 plus 16 is 0. Negative 12 plus 12 is 0, so I have nothing on the left side, 0. And then negative 32 plus 27 is negative 5. Well, that's not a true statement. That's false. So this actually is no solution. This is one of those special cases, giving you a visual. It could be any one of these 3. 3 planes don't intersect all at the same point. 2 planes are parallel and one we have a transversal plane, or we have 3 parallel planes. It's one of those situations. We don't really care which one of those situations, we just know it falls under that category. Let's look at another special case. So again, I like to start out by labeling these 1, 2, 3, just to keep my work organized. Now, analyzing what I can eliminate. So my x's, I have a 3, 6, and 1. My y's, I have a 1, negative 2, 4. Nice that we have an opposite. My z's, I have a negative 2, a 1, and a 3. So I would go for either y's or z's. To switch it up, this time I will eliminate z's, but I would encourage you either y's or z's. If you want yours to look exactly like mine, eliminate the z's with me. So the first thing I'm going to do, let's go ahead and take equation 1 and 2. But let's think, will they cancel out right now? No. So I'm looking at my z's. We need to get those to opposites. So can I get this 1 into the opposite of a negative 2? Yeah, I can multiply it by 2. Oh, I skipped one. That's okay. We'll go back to number 4. So I'm going to multiply this by 2. So I have 3x plus 1y minus 2z equals 10. Second equation now becomes 12x minus 4y plus 2z equals negative 4. Now I'm going to add them. So 3 plus 12 is 15x. 1 plus negative 4 is negative 3y. These z's cancel, equals 6. This is equation A. So I just used 1 and 2. Now I'm going to use, let's say, 2 and 3. That way I don't have to multiply 2 equations. So equation 2 and 3. So I need to get this 1 and 3 to become opposites. Let's make the 1 into a negative 3. So let's multiply our equation 2 by a negative 3. So negative 18x plus 6y minus 3z equals positive 6. Equation 3 stays the same. 1x plus 4y plus 3z equals 7. Time. Now we're going to go ahead and add those. So I have negative 18 plus 1 is negative 17x plus 10y. Z's cancel, equals 13. That's equation B. This is going to be interesting. Equation A, equation B. Just rewriting them together so I can get a good visual. You could skip the step if you don't need it all together. All right, I need to create opposites. So I'm going to go ahead and work with my y's, eliminating the y's. In order to do that, I'm going to make this negative 3 into a negative 30, so multiply by 10. And I'm going to make this 10 into a 30, so multiply it by 3. So 10 times 15 is 150. X minus 30y equals 60. Distribute to every single term. Then distribute the 3. So I have 3 times negative 17 is negative 51x plus 30y equals 39. Add these. So 150 minus 51 or plus negative is 99x. These cancel, equals 99. Divide by 99. X equals 1. Then I take that and plug it into one of my equations. These numbers look prettier. I'm going to go over here. So 15 times 1 minus 3y equals 6. 15 times 1 is 15. Minus 3y equals 6. Subtract 15 on both sides. So negative 3y equals negative 9. Divide by negative 3. Y is now 3. Now I take the x and the y and plug them both into one of my equations. I am going to pick equation 3. You could pick any 3 of the equations. Does not matter. So, I like to rewrite the equation first, so I eliminate my errors. So x plus 4y plus 3z equals 7. I know that x is 1 plus 4 times y is 3, plus 3z equals 7. 1 plus 12 plus 3z equals 7. 13 plus 3z equals 7. 3z equals negative 6. Divide by 3. Z equals negative 2. Throw it all together. My final answer should be an ordered pair. X, Y, Z. So 1, 3, negative 2. So that is the point where the three planes intersect each other. Let's do one last one. This is actually number 4 if you have the paper with you. Equation 1, equation 2, equation 3. All right, when I look at these z's are beautiful. They all have a coefficient of 1, and I do have this opposite z, so I'm going to pair equation 2 with 1 and 3. So my goal is to eliminate z. So first, let's start with equation 1 and 2. So 1 and 2, I'm just going to rewrite them. X plus y plus z equals 4. X plus y minus z equals 4. And add. 1 plus 1 is 2x. 1 plus 1 is 2y. 1 plus negative 1 is 0. Equals 4 plus 4 is 8. Don't forget to add these. Equation A. Then I'm going to take equation 2 and 3 because my z's are already opposites. So x plus y minus z equals 4. 3x plus 3y plus z equals 12. Add them. 1 plus 3 is 4x. 1 plus 3 is 4y. Negative 1 plus 1, 0 equals 16. Equation B. I'm going to merge A and B together so they're next to each other so I can figure out how to manipulate them if needed. All right, if I add them right now, nothing will cancel. So I'm going to go ahead and take my top equation. I'm going to get my x's to eliminate. So I'm going to get this 2 into a negative 4. So I'm going to multiply by negative 2. So this becomes negative 4x, negative 4y equals negative 16. Equation B can just drop down. 4x plus 4y equals 16. Now add them. Negative 4 plus 4 is 0. Negative 4 plus 4 is 0. So on the left side of my equal sign, I have 0. Then I have negative 16 plus 16 is 0. This is a true statement. 0 equals 0. So we don't have to go any further. This is infinite solutions. These three planes intersect at a plane, not a point. So if we look at the visual, infinitely many, instead of intersecting at just one point, like this one here, these planes are intersecting at another plane, or sorry, a line. So they're intersecting on one line.